Okay, so I've had to re-record this video because something happened with the audio on the other one, so I'll just re-record it again. But just to summarize, this is chapter 4i. So today we're talking about parallel and perpendicular lines. This unit is split up into two sections. One section for the general and for students who plan on doing the general maths next year. And then we have another section split up for students who want to do advanced maths next year. Okay, so regardless, you both need to learn this, but it's just like how you apply it is a different scenario. So please just follow for now. For the first half, I will focus on students who plan on doing just general maths, and then I will pause the video for a brief moment, and I'll tell you when to stop watching as well. And then, like for those who plan on doing advanced maths, they can continue watching. Okay, so this is what you should do. You For the general kids, all you're doing is finding the gradients of parallel and perpendicular lines, whereas students who plan on doing advanced maths, they are asked to find the equation of the line as well. But if there are people who want to try and get into advanced maths, I would highly recommend just watching the whole thing. Okay. Um, so parallel lines. Parallel lines are pretty much two lines that have the same gradient in linear relationship, though. So they must have the same m value. That's the most important thing. If you have a look at my graph, in my diagram here, y equals 2x plus 1 in the red and y equals 2x minus 2 in the blue. Um, as you can see, they have the same angle, like going upwards, like the lines, but obviously they're located separately. So, and one thing you should notice is they both have the same gradient, m equals 2 in this case. So yeah, that's what makes it unique, okay? So then I just went over this earlier, but I'll just briefly talk about it. You just need to identify which lines are parallel, okay? So you're given two equations. So what I've done is I've highlighted the gradients for you, and then like you just spot whether they are the same m value or not. So for the first one, y equals 3x minus 1 and y equals 3x plus 4, it's true because m equals to 3. So m equals 3, just like that. For part B, I have y equals 7x minus 2 and y equals 2x minus 7. Clearly false because, different m values, so not the same. Part C is a tricky one. You have to make sure that you're paying attention. Y equals 1 half x minus 1 and y equals negative 1 half x plus 2. So it's false because you have m equals 1 half and m equals negative 1 half. Just remember, for it to be parallel, it must be exactly the same, okay? Same, exact. I shouldn't just mention it's exact as well, okay? So it can't be a sign difference. It must be the same sign as well, okay? For perpendicular lines, you just need to know that when two lines cross, yeah, they create a 90 degrees. That's what we call perpendicular lines, okay? Um, there's a formula that we use to help us find the gradients of the perpendicular lines. Um, so I have m1 times m2 equals negative 1. So this is like the basic of it, the beginning of it. That's where it starts from. And then we sort of manipulate the equation in a way where we're trying to find the gradient of the perpendicular line. And as you can see, the highlighted in the yellow in the box, that's the formula that we use to pretty much answer our questions, okay? So m2 equals negative 1 over m1. Now you might be wondering, what does m1 and m2 mean? It's pretty simple, okay? It just means m1 is the gradient of the line that we're given, and m2 is the gradient of the perpendicular line that we're trying to find here. Okay, that's what you need to do. Sorry, I'll give you some time. Now, let's just go through some examples. So in this question here, we're given what m1 is already, so we can just apply our formula, and all you're doing is just substituting. So when you substitute, it becomes m2 equals to negative 1 over 4, and you're done, just like that. That means the gradient of the perpendicular line for when m1 equals 4 is m equals negative 1 4, 1/4. Now, this is the tricky one, okay? This is tricky, so I need people to start paying attention here. So m1 is negative 2 over 3. It gets a bit weird because just write down our formula first, yeah? Negative 1 over m1. And then when you sub, it becomes m2 equals to negative 1 over negative 2 over 3, which looks completely weird, yeah? Like you might be tripped out right now, but it's nothing too serious, yeah? Just remember the this line here is a dividing sign. That means this will also be a dividing sign right there. What that turns into is negative 1 divided by negative 2 over 3. And if you remember, when you divide fractions, we did something called KCF. Yeah? So keep, change, flip. Okay? And that's all we're going to do. So if you remember correctly, it is keep the first one, change the dividing to a time sign, and then you flip the second fraction. Okay? And now you just multiply fractions like normal. You just multiply across. Okay? So if you remember correctly, another way of writing negative 1 is writing a whole number is just putting it over 1. So if I do that, the fractions can multiply like normal, and I end up getting positive 3 over 2 because negative times a negative is a positive, and then I just have 3 over 2. That means m2 equals to positive 3 over 2, and that's it. You can stop watching from here. Just do the MathSpace which I've assigned. Try and get it all done, okay? It's good practice. It will help you with your chapter 4G stuff as well. Um, but yeah, just keep studying diligently, okay? Please get the work done. I'd hate to see people not do their homework just because of time. So let's just be on top of things, okay? Uh, so please do MathSpace from now on. For chapter 4i, and then that will be your homework for the weekend, okay? Now, this is for people who plan on studying advanced maths next year, okay? It's very similar to 4G. Just follow along. I think you'll pick it up quite easily, but yeah, we'll see how it goes, okay? So let's just try. So find the equation of a line which is parallel to y equals 3x minus 1 and passes through the point 0, 4. Okay, so I've already highlighted the key info for you. Something that should stand out is the word parallel here. Remember, parallel meaning m value is the same. And then this is technically the order that I would write it in, so how I would answer the question. So I'd first start out by writing the formula y equals mx plus c, just so I know what it's going to look like at the end, yeah? Substitute m into your equation. Since I know m is the same as whatever is given to the line, I can say m equals mx plus c. So I think I'll just indicate as step 1, step 2. Now step 3, here say substitute your coordinate point. So I'm just rewriting step 2 first. This is step 2. And in step 3, say substitute my coordinate point. My coordinate point given to me is 0 and 4. So that's just what I'm going to substitute. Okay, so let's just do that. And this here is step 3. Step 4 here, say solve for c, okay? So when I solve for c, I end up with 4 equals to c, 0 plus c, just like that. And then 4 equals c. Now another way of writing this, you can rewrite this as c equals to 4, just to make your life easier to read. And then step 5 says substitute m and c into your equation. So y equals 3x plus 4. There we go. And that's how you would do it. Okay, so you can see how it correlates to chapter 4G, and this will definitely help you in the long run. Okay. Yeah. Let's move on to perpendicular lines. Okay. Very similar vibe to the one from earlier. The only thing you have to do is just technically one extra step. Okay. So the extra step is finding the gradient of the perpendicular line. But other than that, everything else is the exact same thing. Okay. So find the gradient m2 of perpendicular line. So just remember our formula, m2 equals to -1 over m1. And then just identify what is m1. So that there is m1. So now I can just substitute 2 into my equation. -1 over 2. That means the gradient of the perpendicular line is -1/2. Step 2, substitute my gradient of the perpendicular line into the general equation. -1/2 x plus c. Step 3, substitute coordinate points. So let's just write it out. C. And what's our coordinate point here? It passes through 0, -1. So let's just do that. Just like that. Step 4 is here, say solve for c. So now -1 equals to, just remember anything multiplied by 0, um, just, so, okay, they sign, okay? So this now becomes 0 plus c, and I end up with -1 equals c. Rewrite it the other way around, c equals -1, okay? And then step 5 here says substitute m and c into your equation. Well, I've already done what m is. I can now just substitute c plus -1. And just remember these signs can combine here. That now turns to a minus. So your final formula should be -1/2 x minus 1. Okay, just like that. And then you're done. So please do the questions 1 to 4 here. Okay, get it over done with. If you feel like, challenging yourself, do question 7 and 8 as well. Okay. I won't be seeing you on Monday, Tuesday because of my throat. Still a bit weak, so I don't think I can teach properly. Um, but yeah, I'll just make the videos and all that kind of stuff, and you all should be fine, okay? Take care, enjoy the weekend. Please make sure you get that homework done, okay? Like, I don't want people just rocking up to school with empty books. Please make sure, we just try our best, okay? That's what matters the most. Good afternoon, good day.